So you may be asked to identify if a table of data given an X and a Y value is proportional or not proportional. And I'm going to show you two ways that you can go ahead and do that. If you're doing this in your math class, odds are you're going to be learning a lot of times you want to compare the Y value to the X value, where the Y value is on top and the X value is on bottom, especially once you get to unit rate. But just for this, the sake of this video, we'll do the same thing. We'll compare these values with the Y value to the X value, and we're going to make sure that we're corresponding these values with the ones that are next to each other in the table. Our goal is to see if all of these ratios are actually equivalent or not equivalent. So let's go ahead and take a look at the first one right here, the 2 to 3. So this is the first method. The first method is to write it as a ratio, and I'm just going to write it as a ratio, this time as a fraction. And then simplify the ratio if you can. Well, 2 over 3 cannot be simplified any more than that. So we're just going to simply leave it as 2 over 3. Next, we're going to check this next one here, which is 6 compared to 9, or 6 over 9. And this can be reduced. I believe if we divide both of those numbers by 3, that will give us 2 over 3. So far, this and this are the exact same simplified ratio, meaning they are equivalent. So far, this table is proportional. Let's go ahead and take a look at the third one, because if all three are equivalent ratios, then this table is indeed proportional. But let's not jump the gun quite yet. Let's just wait until we double check this last one. We have 10 as our Y value and 15 is our, and we're doing this one here, just so you know, this one was over here. Let's go ahead and simplify this ratio. Divide both of these by 5, I believe. And that will give us 2 on top, because 10 divided by 5 is 2. Divide the bottom by 5 as well, and that will give us 3. Well, look at that, folks. All three of these have the exact same simplified ratio, which tells us that this is indeed a proportional relationship. Give that one a check mark, because it is proportional. Now let's take a look at this second table. Let's do the same exact thing. Let's do the 4 over the 2. For this first one here, because that's the Y value to the X value, just like we said down here. We're doing the same thing, comparing the same in the same order on this second table. That can simplify, I believe, if we divide them both by 2 to 2 over 1. Now let's check this one. We have 8 over 6. Let's divide those and simplify if we can divide by a greatest common factor, which we can. Between 8 and 6, I believe the greatest common factor is 2, which would give me 4 over 3 if I divide them both by 2. I cannot simplify that ratio or that fraction anymore, which means I have 2 over 1 up here. I have 4 over 3 down here. I don't even have to do the third ratio, because I can already tell that these two are not the same, making these two not proportional. So that is going to go ahead and get the X, meaning that this table is not proportional because those ratios were different. Now, the second method that I'm going to show you here, if your teacher allows you to do so, is by using a calculator. So we can pretty much do the same thing that we just did on that first slide, but this time, rather than simplify the fraction, so this first one would be 4 over 5, what we are going to do is we are just going to go ahead and figure out what this is as a decimal. So 4 divided by 5 comes out to be 0.8. Now, I'm sure some of you could have done that in your head, but just for the sake of the video, I'll show you how you can do it with a calculator. And then the next two. So then we would have 8 over 10, taking the Y value over the X value, the ratio of Y to X. And I already know that 8 divided by 10 is going to be 8/10, since it literally reads the same way, but I will prove with the calculator as well. It's tough for me to put a decimal there. Sorry about that. And the third would be 15 over 12, or 15 divided by 12. And that comes out to be, pardon me, did I draw that backwards? Look at that, folks. Let me reverse that here. 12 divided by 15, because it's always the Y value over the X value. 12 over 15. Once again, is 0.8. So this, my friends, would be proportional for that reason. All just like the first slide, here we have the same number over and over and over again, which, by the way, is called the constant of proportionality. If you continually get the same number for all three, if it's proportional, the number that makes it proportional is this 0.8 or 4/5, which would be a simplified fraction. Let's check this last one. We would have 3/5 would be the first for us to turn into a decimal. 3 divided by 5, we're looking like 0.6. 0.6. Sorry, I'm trying to make a decimal there for you. The next one would be 7 divided by 10. Now, I have a feeling that that's going to come out to be 0.7 since it reads as 7/10. Just to prove it to you on a calculator, we have 7 divided by 10, and there it is, 0.7. So, ladies and gentlemen, that tells us that this is indeed not proportional, because just like on slide 1, here we see there being a differing of numbers between this ratio here and this ratio here. I hope that that helps you be able to determine if a relationship is proportional or not simply based on a table. Thank you so much. Have a great day.